Hello everyone. Welcome back to the course of data structures using C language. This video is brought to you by Newton's group of institutions, Macharla. This is Yegireddy from the Department of Computer Science and Engineering. Now, let us see what is an circular linked list. A circular linked list is a sequence of elements in which every element has a link to its next element in the sequence. And the last element has the link to the first element. That means that a circular linked list is similar to the single linked list, except that the last node points to the first node in the list. So here we can say like this: a circular linked list is a variation of the linked list in which the first points to the next element and the last element points to the first element. So here, both the single linked list and double linked list can be made into an circular linked list. So we can have circular single linked list and circular double linked list. Now, if you can see, this is an linked list with 4 nodes and each having 2 parts. One is the data part and the other is the address part. So the address part is holding the address of the next node. And note that it is not compulsory that we have to have the addresses in the ascending order or descending order, because these addresses are created at the runtime dynamically by using the malloc function. So here you can see that the head which is pointing to the first node in the linked list. Now to make this particular single linked list to an circular linked list, we have to make small changes. Now let us see what is the changes what we have to make. So here, if you see in the last node, the address part is containing the value of null. That is, this particular last node is not pointing to any node. Now to make this as a circular linked list, what we have to do is, the address part of the last node, we have to store the address of the first node. And the address of the first node is 2046. So we have to store that 2046 value here, so that this particular node now start pointing to the first node. And now we can clearly see that this particular list is an circular linked list. So here, the last node address part, we are storing the address of the first node. Now my question is, where the circular linked list will start and where it is going to end. Since here any node can be the starting point, so we can traverse the whole list by starting from any point. So we just need to stop where the first visited node is visited again. Suppose if I am starting at the node 3, so the first visited node is at address 9042. So this will be my first node, second node, third node, fourth node, fifth node. When I first visited node link will be 904, I have to stop there. So now let us first see here how to implement the circular linked list, how to create the linked list, and how to display the content in the linked list, and how to delete the nodes in the linked list. Okay, so it is same as single linked list, only this difference what we have to implement is, we have to make small changes to our program while creating the node in a linked list. Now let us see how to write the code. So here the representation of a node in a circular linked list, which is similar to that of how to represent it in a single linked list. So here we write struct node int data struct node pointer link. So in struct node we have two fields, First field is the data field, which is of integer type. And the second field is the link field, which holds the address of the next field. Now, we can declare the pointer variables in two ways. One is like this: pointer root, pointer head, pointer tail, then followed semicolon. Or we can put the semicolon after the struct node declaration and we can write like this. That is struct node, pointer root, pointer head, pointer tail. So any of these two ways can be used for declaring the pointer variables. And can you say why is that we are representing the field, link field, as a struct node pointer type? Why is that it is not here integer, and why it is that it is the struct node pointer? Because if p is a pointer variable of type integer, it means that this p is holding the address of the integer variable. And suppose if p is the pointer variable of type float, then which means that p is holding the address of the float variable. So here the link is a pointer variable which is pointing to the address of the node. So here what is the node? Node is of struct node type. That's the reason here we write struct node. Now let us write the logic for creating a new node in an circular linked list. Void create CL. So here create CL is the function which creates the new node of an circular linked list. As we know that we are going to perform any operations in the linked list by using the temporary variable. So let us first declare one temporary variable with the name new node, which is of struct node pointer type. So a memory will get allocated, say at some location, and which will have the garbage value because our new node is an pointer variable and which is a local variable. Now we have to allocate the memory for the new node dynamically at the runtime. So we do this by using the malloc function. So here we write malloc size of struct node. Now a new node will get created, say at some memory allocation, and say at address 2046. Now this address need to be placed into the new node what we have created. So we have to assign this to the new node. So we assign this to the new node, and here we are doing the type casting, because we know that the malloc return type is void, which is generic pointer type, but new node is a struct node pointer type. So we are implicitly converting that void type into struct node pointer type. So the type casting we are doing here. Now our new node is created. We need to assign the values to it. So we have to assign the value at this location and this location. So by using the printf, we write create, enter the new node, and scanf %d. So here we need to read the data into the address of the new node data field. So here we write ampersand new node to data. Say we have entered the value 10, that 10 will be stored here in the this part. Next, in the new node to link field, what value we have to place? We have to assign the null value. So here it is new node to link is equal to null. Now what we have to do is we have to check the condition whether the root, that is the head, is equal to null or not. So if the head value is equal to null, then we need to assign the head and tail with our new node. So head is equal to tail is equal to new node. Since it is the first node, the head and tail will be pointing to the new node. Suppose that if the head is not equal to null, That means that already there is a node in our circular linked list. So in the what we have to do, again we have to create a new node. So in the else part, what we have to do, we have to create a new node. Say that we have created a new node at dynamically by using the malloc function, and the address is 5048. That 5048 is assigned into the new node. Now what we have to do, since the head is not equal to null, we are coming into the else part. So here what we have to do, we have to place the address of the new node here. That is tail to link is equal to new node. So to connect, to give the connection between these, the new node and this previous node, that is our first node, what we have to do, we have to do tail to link is equal to new node. So tail to link is equal to new node. So now tail to link will get the value 5048. So the connection will be established between these two nodes. Now what we have to do, this is the new node and this new node is the last node. So we have to shift this tail to this location. So that is tail is equal to tail to link, or tail is equal to new node. We are going to move to this location. Now what we have to do, since this is a circular linked list, at this place we need to store the address of the first node, that is the 2046. What is 2046? Head. So our tail to link should be assigned with the value of head, so that 2048 will be placed here and our new node will be pointing to the first node. So this is how we are going to create a circular linked list. Now let us see some of the important operations that are being supported by the circular linked list. The first operation is insertion. That insertion can be done in three ways. Either in the insertion can be done at the beginning, or insertion can be done at the end, or insertion can be done at the specific location. Now let us consider a circular linked list with 4 nodes with head pointing to the first node and the tail pointing to the last node. So head is pointing to the first node and tail is pointing to the last node. So this is our circular linked list. Now let us insert a new node at the beginning of the linked list, circular linked list. So before writing the logic, let us draw the structure of the circular linked list after adding the node at the beginning. Now, so let this be the new node what we would like to insert at the beginning, and we created this node dynamically by using the malloc function. So by using the malloc function, we have created the new node, and that new node, what we are doing, we are adding at the beginning. Say that the memory got allocated at some address, say at 5000. Now our new node got created, and this new node we are adding at the beginning. Now what we need to do, we need to assign the values to this particular new node. So what we have to do, we have to read the data into this data part by using the scanf function. So printf, enter the node, a new node data, scanf %d ampersand new node to data. Say we have entered the data value as 5, the 5 is stored here. Next, the value of the new node to next. So here the value of the new node to next should be this address, that is 2046 address. What is 2046? It is head. So here what we have to do, new node to link part, we need to assign the value of the head. So new node to link will be equal to head value. So here 2046 value will get placed, and now thus the connection will be connected like this. Now what we have to do? What we have to do? We have to move the head part to this part, because this is the first node now. So the head should be moved to this location. So how we can move? Head should be equal to new node value. Head should point to the 5000 address. So head is equal to new node. So head value will be 5000 and the head will be pointing to that particular node. Now what is that? The last node should point to the first node. 2046 is not the first node. The address of the first node is 5000. So here in the last node we have to place the 5000 value. So how we do? Tail to link. Tail to link is equal to head. Head value is 5000. So tail to link is equal to 5000. So the 5000 value will be getting stored here and we will have a connection that will be pointing to the first node. So this is how we can insert a new node at the beginning of the linked list. Now let us see the second case, that is inserting a node at the end of the circular linked list. Now again, let us go with the same example. Let us consider the linked list with 4 nodes having pointing to these nodes, where the first node is pointing to the head node is pointing to the first node and the last node is pointing to the tail node is pointing to the last node. Now here we are inserting the new node at the end of the list. So here we have to insert the new node at the end of the list. So before writing the logic, let us see the structure of the circular linked list after adding the node at the end. Now let us suppose that this is the new node what we would like to insert at the end of the circular linked list. That new node what we are doing is we are creating by using the dynamically by using the malloc function, say at some address, random address 5000. Now what we need to do, we are assigning that value to the new node. So our new node will be pointing to this one. Now what we have to do, we have created the new node. Now we need to assign the values. So by using the scanf function, we can insert the data into the new node, scanf %d ampersand new node to data. So in the new node to data field, whatever the value you enter, say suppose we have entered the 50 will be stored here. So now what we have to do, we have to make the tail to link value, that this value should be with this address, not with the 2046. So tail to link should have the new node value. So we need to write tail to link is equal to new node. So my tail to link, once after that statement, it will be 50 and it will be pointing to this particular. And next what we need to do, we need to, because this is our last node, now we need to shift the tail to the last node. So here the tail will be equal to the new node value. That is, it should point to the 5000 address. So tail is equal to new node. So now my tail will be pointing to the last node. So the tail will be pointing to the last node. Then the tail to link should be holding the address of the first node. So here what we have, we should have the address of the first node. So here we write tail to link is equal to head value. That is 5046 value. So now we are going to have this particular connection. So this is how we can insert the node at the end of the circular linked list. Now let us see the third case, that is adding the node at the specific location. Now again consider the same example, that is with 4 nodes, where the head is pointing to the first node and the tail pointing to the last node. So head is pointing to the first node and tail is pointing to the last node. Now we are inserting the node at a specific location. So we have to read the location value. So printf, enter the location. Then we need to scan the location value. So if the value is within the limit, then we need to insert the new node at the specific location. Suppose the location value what you have given is 7, entered is 7. Then it will print the message invalid location. Suppose that the location value is 3. Then what we have to do? we have to insert the new node at this. So let us first create the new node by using the malloc function, and that we are assigning to new node. Say suppose at the address 5000 it got created. Now what we have to do? We have to give the values. Node got created. Now this node we have to insert in between these two nodes. Now the values need to be given. Say that we are giving the values. For that, what we are doing is we are creating a temporary pointer variable with a head pointing to the root node. Now, to insert this particular node, which is with 35 value at this location, we need to bring the temp control to this particular location with address 9042. For that, the logic what we are writing is for I is equal to 1 to I less than location I plus plus, temp is equal to temp to link value. Now, my temp value, I value is 1. 1 is less than location value 3. Condition is true. So, temp will be equal to temp to link. What is temp to link? 2046 to link is 5048. So, 5048 will be stored in the temp. Now again I plus plus. Now my I becomes 2. 2 is less than 3. So again we enter into temp to link. 5048 to link is 9042. So 9042 will be stored here. Now again I plus plus. I value will become 3. 3 less than 3. Condition is false. So we come out of this loop. So by the time we come out of the loop, my temp is pointing to this particular location at the address 9042. Now what we need to do? We need to connect this location here and this location here. So which location first? Right side location connection first. So right side means we have to give the new node link value with 7052. What is that 7052? Temp to link value. Temp to link value is 7052. That 7052 value we have to assign here for the new node. So here we write new node to link is equal to temp to link value. So now 7052 value gets stored here and this connection got connected. Now we have to make this disconnected and we have to connect this link here. So we have to disconnect. So here we have to place the value of 5000. What is 5000? 5000 value is new node value. And what is this place? This place is nothing but temp to link. So in temp to link value, we need to assign the value of new node. So now 5000 will be stored here and it will start pointing to this particular node. Now we have inserted the new node at the specified location 3. That is after the location value 3, we have inserted the node. So this is the logic what we have to use for inserting the node at the specific location. Now let us see how to display the elements in our circular linked list. So let us see the second operation, that is how to display the elements in a circular linked list. So for that we write the function void display. So the same story repeats once again. We need to declare the temporary variable. So here void display function we are using. Now we need to declare the temporary variable which is pointing to our root. So struct node pointer temp which is equal to head value. So the temp variable is also pointing to the first node. Now what is that? We have to traverse until the last node. So how to traverse from starting? So first node we have to display, then we need to go to second node, then we need to display the value of second node, then we need to go to third node, then display the third value, then we need to go to fourth node, then display the fourth value. So for that, the logic what we are writing is while temp to link not equal to head value. So here, what is the temp to link? Temp to link is temp value is 2046. 2046 to link is 5048. 5048 is not equal to head value. So what we are doing? We have to display this particular node data. So printf %d, we have to temp to data. So after that, what we have to do? We have to go to the next node. So temp is equal to temp to link. So what is temp to link? Temp is equal to 5048. So now 5048 will be stored here. 5048 is not equal to 2046. 5048 is not equal to 2046. So 5048 is not equal to 2046. It will display the second element. Now temp is equal to temp to link, that is 7052. Sorry, first temp to link 5048 not equal to head, so it will display 10. 9042 not equal to head, it will display 20. 7052 not equal to head, it will display 40. 2046 is equal to head, so it will not display 40. It will come out of the while loop. Then once after coming out of the while loop, what I am doing, I am printing percentage d temp to data. So I am printing the value of 40. So this is the logic what we are going to use for printing, displaying all the nodes that are node data in the circular linked list. Now let us see one more operation, that is a delete operation. So now let us see the next operation, that is deletion operation. So here again, what we will discuss all the three cases, that is deleting a node from the beginning, deleting a node from the end, and deleting the node from the specific location. Now let us consider the same example of the circular linked list with 4 nodes. So here are the 4 nodes with the different addresses, because they are dynamically created with connections. And here the head value is 2046 and the tail value is 7052. So the head will be pointing to the first node and the tail will be pointing to the last node. Now let us see how to delete the node at the beginning. So here we have to delete this particular node with the data value 10 values. So now we have to delete this node. So after deleting the first node, the structure of the circular linked list will be like this. For deleting at the beginning, to delete, first we need to have to assign the head value to 10. So we have to assign the head value to the 10. And second, what we have to do? We have to move. What we have to do? We have to move the head to the second node. So since we are deleting this particular node, our head should point to this location. So what is that? Head is equal to head to link. So head is equal to head to link. So now my head will be 5048. So head will be pointing to this particular location. Now what we have to do? We have to bring this particular pointer pointing to the first node. What is our first node? 5048, not 2046. So we have to place tail to link is equal to head value. The head value is 5048. So 5048 will be placed here. Now the connection will be like this. Now what we have to do? We have to disconnect this connection. We have to remove this connection. So how we can remove this connection? Who is pointing to this particular node? Temp is pointing to this particular node. So we have to place the temp to link value as null. So our temp to link value will be null. So once when it is null, the connection is gone. Now what we have to do, because we have created all these nodes in the circular linked list dynamically by using the alloc function, we can free the memory so that we can reallocate the memory for some other purpose. So for that, what we are going to do is we are freeing the memory by using free of temp. So that particular memory will get reallocated. Understood? Can be used for some other purpose. This is how we can delete a node from a circular linked list at the beginning. Now let us see the second case, that is deleting node from a circular linked list at the end. So now we are using the second case. So how to delete the last node in a circular linked list? That is what we are seeing. So the same linked list we are considering, that is with the 4 nodes connected like this. So first node connected to the second node connecting to the third node connecting to the fourth node, and the fourth node connecting to the last node, which is our head node, and the last node is our tail node. So this is how we are giving the connections. Now, so this is our head node and this is our tail node. So in this case, after the deletion, the structure of the linked list will be something like this. So here we are removing the linked list. So this will be our last node. So tail should point to this node. And here the address, next address should be 52046. Understood? So here for that what we are doing is we are creating an temporary variable. So we are creating two temporary variables, one temporary variable which is pointing to the head node and the other temporary variable which is pointing to the tail node. I will say why we are using the second temporary variable. So we will understand the importance of this particular temporary variables while in the process. So here temp1 which is pointing to head node, we need to bring this temp to this particular node because we are going to delete this node. We have to. So for that, for the logic, what we are writing is while temp1 to link not equal to tail value, temp1 is equal to temp1 to link. So here first the temp1 value is 2046, head value 2046 to link is 5048. 5048 is not equal to 7052, so it will move here. Now 9042 is not equal to 7042, so we will move here. Once after moving here, 7052 is equal to the tail value, so we will not move here, we will stop here. So the tail will be start pointing to 9048 address. So this is the logic what we have to use for making the pointer of temp1 to point to this particular memory location. Now what we have to do, we have to delete this particular node. So for deleting that particular node, what we have to do, we have to bring our that tail to this location. So what is the address of that location? 9042. So 9042 need to be in the tails place. What is that? Temp1. So tail is equal to tail to link value. So here in the tail to link value, we are placing the null value. So this connection gone. Now I am bringing the tail to this location. That is tail is equal to null. Tail to link. Sorry. Tail is equal to temp1. So when my tail is equal to temp1, it will be start pointing to this location. So previously it was here. When I write tail is equal to temp1, temp1 value is 9042. So my this pointer will be, tail will be pointing to this location. Now what we have to do? We have to make this connected to this first node. That is tail to link will be equal to the head node. That is 2046. So the pointer will be pointing to this particular node. Now this got disconnected completely. So what we have to do? We have to free the memory. So how we can free? By using the free function. So how we can free this node? This node is 7052 address. Who is pointing? temp2 is pointing. So free of temp2. For that reason itself, we have taken this second variable. So free of temp2 is equal to, so this node will get free. Now we can reallocate it. Now let us go with the third case, that is deleting a node at a specific location. So now we are going to delete a node from a specific location. So again we need to consider the same example with the 4 nodes where the connections are being like this with values 10, 20, 30 and 40. And the head node which is pointing to the first node, that is address 2046, and the tail node which is pointing to the last node, that is with address 7052. So head will be pointing to this particular node and the tail will be pointing to this particular node. So head is pointing to the first node and tail is pointing to the last node. So the connections are like this. So this is the circular linked list. So now we are going to delete the node from a specific location. Say to delete a node, first what we have to do, we have to enter the location value. So printf enter the location, scanf %d ampersand LOC. So that location value, of course, we have to declare, that is a local variable. Say suppose the location value is 5. Then what? We have only 4 nodes, but we are entering we want to delete the 5th node, which does not exist. So we need to print an error message saying that invalid location. Suppose that if the location value what you have given is 3. So you have to delete this particular node. When you say the location value 3, you have to delete this particular node that is present in this particular third location. So for that, what we are doing to make this logic work, we are creating again here 2 temporary pointer variables, temp1 and temp2. So here we are creating struct node temp1 which is pointing to head 2 and temp2 which is having the garbage value. Temp2 is having the garbage value. Temp1 now it is pointing. So we have to make the pointer temp1 point to this particular location. So for that the logic what we are going to write is for I is equal to 1 to I less than location minus 1, not location, location minus 1 I plus plus. So here now my I value is 1. 1 is less than location minus 1, that is 3 minus 1, 2. So temp will be temp to link, that is temp will be initially the temp value is equal to the head value 2046 to link is 5048. So 5048 got stored here. Now I plus plus I will become 2. Location minus 1, 3 minus 1 is 2. 2 less than 2 condition is false. So my pointer temp1 will be pointing to this location and it will come out of the for loop. Now what we have to do, we have to make the temp2 to point to this particular location. So how? To this particular address we need to point. So it is a temp1 to link. So temp2 is assigned with the value temp1 to link. Temp1 to next or temp1 to link. So here in this case it is link, not next. So our temp will be pointing to this, temp2 will be pointing to this node. Now what we have to do? We have to delete this particular node. So our connection need to be from here to here. So we have to remove this connection and we have to remove this connection. So how to remove this connection? So here we have to place the value of 7052. So what is 7052? It is not a tail value because maybe of course in this case it is the tail, but always we know we don't delete the last but one node. We can delete any node in the middle. So in our logic, don't write tail to link a tail value. So here the value what we have to place is, we can do it in 2 ways. One is it can be temp to link value, or it can be temp2 to link value, or it can be temp1 to link value. So here the logic is temp1 to link is equal to temp1 to link is equal to temp1 to link. So then it will be pointing to 7052 address and it will be pointing here. Now what we have to do? We have to remove this connection. So how to remove this connection? Temp2 is pointing to this node. So temp2 to link is equal to null. Now that connection got disconnected. So this is our circular linked list. But before that, what we have to do? We have to free this node because we have created this node dynamically by using the malloc function. So we write free of temp2. So when we say free of temp2, that node will get erased. So we can use it for some other purpose. So this is how we can delete the node for the at a specific location. So this is the logic what we are going to use for deleting a node at the specific location. So that's all for now. Thank you. If you like this video, please subscribe to my channel and press the bell icon for the latest notifications. Thank you, one and all.